Hello friends, today's we have learned the subject chemistry of biomolecule in which the chapter carbohydrate. So in which we are studying the introduction of carbohydrate, then the properties, classification, then example and function of carbohydrate. First, the definition of carbohydrate. The carbohydrate are a group of naturally occurring carbonyl compound that also contain several hydroxyl groups. It may also include their derivative which produce the such as compound on hydrolysis. There are most abundant organic molecule in nature and also referred to as saccharide. The carbohydrates which are soluble in water and sweet in taste are called as sugar. The carbohydrate is called as a sugar because it's soluble in water and sweet taste. Next, structure of carbohydrate. The carbohydrate consists of carbon, hydrogen and oxygen. The general empirical structure for a carbohydrate is CH2ON. They are organic compound organized in the form of aldehyde or ketone with multiple hydroxyl group coming off the carbon chain. The building block of all carbohydrate are simple sugar called as monosaccharide. A monosaccharide can be polyhydroxyaldehyde means aldose or polyhydroxyketone means ketose. Next, the carbohydrate can be structurally represented in any of the three forms. First one is open chain structure, second hemiacetal structure, third Haworth structure. So open chain structure, it is a long straight chain form of carbohydrate. Hemiacetal structure, here the first carbon of the glucose condense and with the OH group of the fifth carbon and to form ring structure. Third, Haworth structure, it is a presence of pyranose ring structure. Next, carbohydrate, the classification of carbohydrate. The first classification is monosaccharide, then disaccharide, oligosaccharide and polysaccharide. So monosaccharide examples the glucose, fructose and galactose. Disaccharide example sucrose, lactose, maltose and oligosaccharide example raffinose, stacose. Polysaccharide example starch, glycogen and cellulose. The first is monosaccharide. So what is meant by monosaccharide? The simple carbohydrate include single sugar and polymer, oligosaccharide and polysaccharide. So simplest group of carbohydrate and often called as a simple sugar, and since they cannot be further hydrolyzed, the monosaccharide it cannot be hydrolyzed. The monosaccharides are colorless crystalline solid which are soluble in water and insoluble in non-polar solvent. These are compounds which possess a free aldehyde or ketone group. The general formula is CnH2O or CnH2nON. They are classified according to the number of carbon atom they contain and also on the basis of the function group present. The monosaccharide thus with 3, 4, 5, 6, 7 carbon are called triose, tetrose, pentose, hexose, heptose, etc. and also as aldose or ketose depending upon whether they contain aldehyde or ketone group. Example glucose, fructose, erythrose and ribulose. The chemical structure of some monosaccharide. So these are the structure of monosaccharide, glucose and fructose. Next, the properties of monosaccharide. So most monosaccharide have a sweet taste. They are solid at a room temperature. They are extremely soluble in water. Despite they have high molecular weight, the presence of large number of OH group make the monosaccharide much more water soluble than most molecular weight. Glucose can dissolve in minute amount of water and to make a syrup. That means 1 gram example आहे 1 ग्रॅमला 1 ml वॉटर टाकलं तर त्याचं एक सिरप तयार होतो. नेक्स्ट डायसॅकराइड. the two monosaccharides connected by glycosidic bond. The disaccharide is also called double sugar. Any substance that is composed of two molecules of a simple sugar linked to each other. The disaccharides are crystalline water-soluble compound. The monosaccharide within them are linked by a glycosidic bond, the position of which may be designated alpha or beta or combination of the two alpha beta. The glycosidic bond are cleaved by enzyme known as glycosides. The three major disaccharides are sucrose, lactose and maltose. Sucrose, which is a form of photosynthesis in green plant, consists of one molecule of glucose and one of fructose bonded via the alpha and beta linkage. The lactose found in the milk of all mammals consists of glucose and galactose connected by beta linkage. In maltose, a product of breakdown starch during the digestion, they consist of two molecules of glucose connected by the alpha linkage. Another important disaccharide, trihalose, which is found in single cell organism and in many insects. Also, it consists of two molecules of glucose and the alpha linkage, but the linkage is distinct from the one found in maltose. So this is the structure of disaccharide. Next, oligosaccharide. Oligosaccharides are compound sugar that yield 2 to 10 molecules of the same or different monosaccharide on hydrolysis. हायड्रोलिसिस केल्यानंतर ऑलिगोसॅकराइडचा त्याच्यापासून 2 to 10 मोनोसॅकराइड फॉर्म होतात, त्याला ऑलिगोसॅकराइड म्हणतात. द मोनोसॅकराइड युनिट आर जॉईंड बाय ग्लायकोसिडिक लिंकेज. It is based on number of monosaccharide unit. It is further classified as disaccharide, trisaccharide and tetrasaccharide. The oligosaccharide yielding two molecules of monosaccharide on hydrolysis is known as disaccharide, and the ones yielding 3 or 4. Then polysaccharides. Next one is polysaccharide. So they are also called as glycans. The polysaccharide contain more than 10 monosaccharide unit and can be 100 of sugar unit in length. They yield more than 10 molecules of monosaccharide on hydrolysis. The polysaccharides differ from each other in the identity of their recurring monosaccharide unit, in the length of their chain, in the types of bond linking unit and the degree of branching. They are primarily concerned with the two important functions, that is structural function and storage the energy. The important function is storage the energy. Next is function of polysaccharide. So polysaccharide have several roles. Polysaccharides such as starch, glycogen and dextrins are all stored in the liver and muscle to be converted to energy for the later uses. The amylose and amylopectin are polysaccharide of the starch. Amylose has a linear chain structure made up of 100 of glucose molecule. It is a link by alpha-1,4 glycosidic linkage. And due to the nature of this alpha-1,4 bond, the macromolecule often assume the bent shape, and the starch molecule form halo helix that is suitable for easy energy access of storage. Next, reducing sugar. See, the glucose, D-mannose and D-fructose, these are the reducing sugar. The reducing sugar have a free aldehyde or ketone functional group. reducing sugar मध्ये aldehyde आणि ketone हे जे फंक्शनल ग्रुप असतात ते फ्रीली असतात. So this is a reducing sugar and non-reducing sugar. Example of reducing sugar is D-mannose and D-glucose. All aldose are reducing sugar. All hemiacetal on the anomeric carbon are reducing sugar. Non-reducing sugar, all acetal at the anomeric carbon are non-reducing sugar. So what is reducing sugar and non-reducing sugar? Any carbohydrate that is capable of causing the reduction of some other substance without being hydrolyzed. The first is the reducing sugar, and whereas the sugar that do not possess a free ketone or an aldehyde group is called as non-reducing sugar. Reducing sugar means in which the free ketone or aldehyde group, or the non-reducing sugar means in which the sugar that contain do not possess free ketone or aldehyde group. Next, mutar rotation. The phenomena, it occurs as a result of the interconversion of one anomer to other, is called as mutar rotation. This is because of alpha D glycopyranose begin to transform into its open straight chain counterpart, and which then either turns back into the alpha anomer or goes on to form the beta anomer. So mutar rotations means the interconversion of one anomer to other. Next, the inversion of beet or cane sugar is the chemical conversion of saccharose in solution into glucose and fructose. This process is enhanced by acid and high temperature T. The angle of rotation of polarized light sent through the solution change during the process of inversion. See the specific rotation. Alpha D glucose specific rotation is positive. Specific rotation is denoted as alpha D 20, and alpha D glucose has specific rotation is a plus 112 degrees Celsius, and the beta D glucose the specific rotation is plus 18.7. See the reaction. The D ribose on a reacted with the HOBr, so to form ribonic acid. Second one, D ribose is reacted with the concentrated diluted HNO3, so to form ribaric acid. Here the CH2OH is converted into the acid, that is COOH. Next one reaction, the glucose is reacted with the phenylalanine C6H5NH2, so to form a glucosamine. Thank you.